Welcome back. In part 3, we are now ready to start with our simulation. First, let's fix the settings to be Fluent. By using the default model, QMXST, new changes here. Select OK, exit. Then with our inlet, we'll be using magnitude direction. The velocity magnitude is 14.6. Since our Reynolds number is 300,000, X component is 1, Y is 0, so the angle of attack is 0. And I just will leave that one, apply. All surfaces, intended surfaces are wall. Reference values will be computed from the inlet. Area is 0.3 meters square. Since the chord is 0.3, this is per unit span, just one. There are only one reference zone, so you just leave that. Methods, coupled, and everything else will be second order. I've unchecked the convergence criteria because supposedly you should only stop your simulation once your CD and CL is constant. Okay, next, CL and CD report plots. Okay, initialize. More settings. I can choose external arrow settings and initialize. Okay, now I can run the calculation. I will select 300, which is small enough, and calculate. Okay, stop, drop. CL and CD seems to be a stable right now. CD seems to be constant. So CL, I think I can start now. For the sake of this example. Here under results, you can go to plots, results, plots, XY plot. The step will be to select under mesh for your y-axis function and select X face area. Okay, let me do some explanation. We are only extracting the static pressure as well as the strain rate at the location of y plus. But we still need the unit vector to resolve the forces into its component x and y, lift and drag. So we are actually using the unit vector from the surface, but only using the forces on the y plus region. Okay. So for the x face area and y face area, I will be extracting the values from airfoil blowing holes. Okay, and right now the position is absolute because our maximum is 0.3 meters. But say if you want it to be in terms of as if it is x by c, what you can do is since mine is 0.3, I can just multiply it by 3.3233, and the maximum will now be 1. So the position afterwards will become as if it is x by c. So it will be easy for you to post-process. Okay. New folder, part 3, to store the information. X face area. Okay, that's Y face area. Do the same thing. Now let's see for the static pressure at the Y plus location. Now just to show you the difference, let's plot together the location at the wall as well as at Y plus. This overlapping each other. And see, let's just go back a bit. Okay, here. See, it's overlapping each other. Almost exactly. But there will be some difference in the derivatives. Strain rate. This is to get our shear stress. Strain rate times mu will get our tau. Okay, this is for the Y plus. And now I'm going to include walls. You can see there's some difference here because the boundary layer is growing. So the level of strain rate is deviating as it grows up, as it evolves downstream. And that is even our Y plus is very small, 0.021 mm if I'm not mistaken. Anyways, this value is sufficient. Let's write to file strain rate Y plus. Okay, now we are in Excel. I'm going to call out the data that we have saved just now. First, X face area, transform data, change the data type to decimal numbers, replace current, and close the window. Keep. Then I can sort the values from smallest to largest. The same thing for Y. Transform data. Data type is decimal. Replace. Keep. See, the reason why I converted from something text to decimals because it is not in order for the X by C. This is the X by C column, and this is the Y face area. See, it is skipping values. 75 is here, 74 is here, 70 is there. So after changing it into decimal, I can just sort the values from smallest to largest. So the X by C is growing accordingly. Okay, for X face area, I'm going to just copy everything and paste in sheet 1. Paste as values. That is X by C. And this is X face area. Okay, let's make another column for the Y. Copy and paste. Okay, just to double check, you can see column C and E, they're equal. So the information on the X face and the Y face area is accordingly. Now in this tag and in this, what we call this PDF, I found a tutorial on how to display face normal. Actually, it's just straightforward. We have this values here. I think we learned it in our vector class. So we have AF, which is a function, x face area square plus y face area square. You don't have z, and then just square root that value. And then for our unit vector x, just x face area divided by AF. Same thing with y. So I'm just going to snip this information, this formula, and then just paste it here. Easier for you to follow. The next, okay, next column will be AF equal bracket x face area to the power of 2 plus bracket y face area power of 2 close bracket and to the power of half. Okay, now we have x, we have y. This is our unit vector. I'm going to merge cell and center unit vector. Okay, x is just equal to x face area divided by AF. Y is just y face area divided by AF, and just double click and it will fill in. Okay, now this is something odd because this is 0.999 and then suddenly it's 1. And then we can see that the Y face area is small here and then is growing there. Okay, so we might want to do something about that. Okay, let's go back to Fluent. Plot mesh Y face area. See, there are 2 points here. She's suddenly off. This is at 588 and this is 594, 595. So I'm going to exclude the data for those, the first and the last row. Okay. Just highlight it in a different color, perhaps orange or peach. The first and the last. Okay, 5922, 5858. Okay, now we're just going to continue. I'm going to extract data for the static pressure. Transform data. Text to decimal number. Replace. Close the window. Keep. So you can see that. Sorry, let me just go back. You see that these two values are the same, so we can remove one of them. This is just maybe some discretization error. Row 5 and 6, just delete one of them. Okay, it's important for you to check. Okay, static pressure seems to be okay. Copy, paste, static pressure. Next will be our strain rate. Transform data. Decimal number. Replace. Close the window. Keep smallest to largest. Okay, same thing. There are two rows which gives the same values. So we're going to delete one of them. So I'm going to delete row 6. Oops, I don't need to do both. Escape. This one. Okay, these values. Strain rate. Okay, mu and ds. ds is the length of the individual segment which we did in ICM. If you can recall, in during measuring, the distance is something like 0.0006. Because our blowing range is 60 mm and we divided by 100, so we can roughly estimate it as 0.0006 m. So this is lift, drag, copy and paste. Top will be due to pressure, and this one will be due to viscous. Mu is just 0.00017894. This is 0006. Yeah, let me just take a quick snip. Okay, the unit vector that we have right now is to cater for pressure. Okay, we have this y value and x. This is lift and this is drag. But for tau, it is perpendicular to each other. So we can see that this is y and this is x. I mean, in terms of the length. Okay, for lift, we are going to use I'm going to start from the second row. Y times the static pressure. So we have the direction. Now it times the force is just pressure is just force over area. Now it's 2D. So instead of area, we are just going to use length. So this is ds. Okay, same thing with the drag. First to get x times static pressure. So that is the component in x and times ds. So now we have force. For viscous, lift will be x. Now you times by strain rate. This is just a careless mistake. I'll redo this afterwards. It's just y. Supposedly it is strain rate times mu. times ds. Okay, this is, we also can exclude the last row. Okay, now we're just going to correct the stream rate. Okay. The lift, total drag. So lift due to pressure plus lift due to viscous effect, drag due to pressure, drag due to viscous effect, and these are the values. Okay, let us see what Fluent has to report. Forces. So we are comparing only for the blowing region, right? So hose and wall. So 0 x0 y1. So this is lift, print. Can just make a quick snip. These are the values for lift. Total forces 2.84. Let us compare. Ours is, let's go back and let's copy. Paste. Okay. Now let's do for drag. X is 1, Y 0, print. Okay, this is drag, total 0.1657. Go back to Fluent, copy the total value. And paste. Let's do the percentage error. First bracket, divide by 2.84. Change it to percentage, open the decimal places, so it's very close to each other. Okay, so that sums up everything. Thank you, and I hope this is useful for you.